You're seeing the universe the wrong way. Stars, galaxies, even the birth of planets, all of it is invisible to you without a space telescope. Right now, while you're watching this video, machines are floating in space, seeing what your eyes never could. Want to know how they work? Looking up at the sky with the naked eye might seem like enough. After all, we can see stars, the moon, maybe a few planets. But that's just a tiny fraction of what's really out there. Earth's atmosphere is great for life, but terrible for astronomy. It acts like a filter, distorting, blocking, hiding. The light from stars reaches us flickering, scattered, incomplete. And worse, some types of radiation like X-rays, ultraviolet, and far infrared don't even make it through. That means a huge part of the universe is invisible to us from down here. Imagine trying to observe the ocean floor from inside a submarine with a dirty, shaking window. That's what ground-based telescopes are dealing with. And on top of that, we have light pollution. Cities wash out the night sky. Even the best Earth-based observatories, in places like the Atacama Desert or Hawaii, still suffer limitations just by being on the planet. So the solution was bold. What if we took the telescope off the Earth? By placing these machines in space, we eliminate all the noise caused by our atmosphere. Up there, the universe comes into focus. No distortion, no blocked wavelengths, no interference. Just clean, uninterrupted cosmic light. That's how telescopes like Hubble, Spitzer, Chandra, and now James Webb completely transformed how we see the cosmos. With them, we've spotted galaxies that existed when the universe was just a few million years old. We've discovered planets orbiting distant stars. We've watched black holes devour matter. And we've captured images so deep they feel like science fiction. All of it became possible because we chose to look at the universe from where it can truly be seen, space. When we look up at the night sky with the naked eye, we see only a fraction of what truly exists in the universe. That's because Earth's atmosphere blocks a large part of cosmic radiation and distorts starlight. That's exactly why, over the decades, science has invested heavily in building space telescopes, instruments capable of observing the universe with a precision far beyond what any ground-based observatory could achieve. One of the pioneers in this revolution was the Hubble Space Telescope, launched in 1990. Since then, it has captured stunning images of distant galaxies, massive nebulae, and even evidence of black holes. Hubble became a true window into the cosmos and changed how we see the universe. But it wasn't alone. The Spitzer Space Telescope, launched in 2003, operated in the infrared, revealing regions of space hidden behind cosmic dust, like stellar nurseries where new stars are born. Meanwhile, the Chandra X-ray Observatory helped us understand extremely energetic phenomena, such as supernova explosions and galaxy collisions. More recently, the James Webb Space Telescope entered the scene. It's the most advanced telescope ever built and can observe the very first galaxies that formed after the Big Bang. Additionally, Webb is analyzing atmospheres of planets beyond our solar system, searching for chemical signs that might indicate life. There's also Kepler, responsible for discovering thousands of exoplanets. Gaia, mapping with incredible precision the positions and motions of billions of stars. And Fermi, monitoring gamma-ray bursts, the universe's most violent explosions. Each of these telescopes sees a different part of the electromagnetic spectrum. Together, they form an observation network covering everything from radio waves to gamma rays, allowing humanity to witness the universe in all its complexity. The James Webb Space Telescope is the most advanced and sophisticated machine ever built to observe the universe. Launched in December 2021, it represents a revolution in astronomy, capable of seeing the cosmos in unprecedented detail. But what exactly makes James Webb such a special instrument? First of all, Webb is not just a traditional telescope. It's a full observatory equipped with technology that allows it to capture light invisible to the human eye, mainly in the infrared spectrum. This is crucial because infrared can penetrate dense clouds of cosmic dust that block visible light, allowing us to observe regions where stars and planets are being born. Its primary mirror is made up of 18 hexagonal segments crafted from beryllium, together forming a massive 6.5-meter diameter mirror. almost 3 times larger than Hubble's. This huge size lets it gather more light, essential for observing extremely distant objects whose light has traveled billions of years to reach us. Besides its size, the precision of these mirrors is impressive. They are coated with a thin layer of gold, which improves infrared light reflection. Each segment can be individually adjusted by tiny motors, ensuring the whole assembly acts as one perfectly aligned mirror. Another vital part of James Webb is its sun shield, a massive thermal filter roughly the size of a tennis court. This shield blocks radiation from the sun, Earth, and Moon, keeping the telescope at extremely low temperatures, around -220 degrees Celsius. This cooling is critical, so the infrared sensors work correctly, as any heat emitted by the telescope itself could interfere with observations. Webb is positioned at the so-called L2 point, about 1.5 million kilometers from Earth, where the gravitational forces of the Sun and Earth balance out. This allows it to maintain a stable position and receive constant light from the universe, far from Earth's atmospheric and thermal interference. Its 4 main cameras and spectrographs are capable of a vast range of studies. They can capture high-resolution images, analyze the chemical makeup of exoplanets, study star and galaxy formation, and even investigate the light from the first objects formed after the Big Bang. This versatility makes James Webb a unique tool to answer fundamental questions about the origin of the universe and the possibility of life beyond Earth. The data collection process is equally complex. The telescope focuses on specific targets, while its instruments detect individual photons of infrared light. This data is processed to produce detailed images and spectra revealing the composition, temperature, motion, and other characteristics of observed objects. James Webb has already provided images and information that challenge our previous ideas, revealing galaxies older and more complex than we imagined. It shows that the young universe was a more turbulent and active place, with intense star formation and constant cosmic interactions. Moreover, Webb is revolutionizing the study of exoplanets by analyzing their atmospheres. It can identify molecules, like water, methane, carbon dioxide, and other gases that may indicate conditions favorable to life. This is something no previous telescope could do in such detail. How did the James Webb Space Telescope get so far from Earth? It all started with its launch on December 25, 2021, aboard an Ariane 5 rocket, capable of carrying its massive 6.5-ton load into deep space. It followed a path to the Lagrange point, 1.5 million kilometers away, where the gravitational forces of the Sun and Earth balance out. There, Webb remains almost stationary, floating in a halo orbit. To maintain this, it uses small thrusters that make fine adjustments to its position, consuming hydrazine fuel stored in internal tanks. This fuel is limited and determines how long the telescope can operate. Currently, the mission is expected to last at least a decade. All control of Webb is done remotely by a team on Earth. They plan observations, monitor systems, and receive data through high-powered antennas, despite about a 5-second delay in communication due to the distance. The telescope can quickly change the direction of its mirrors and sensors thanks to attitude control motors, ensuring sharp and precise images, but it cannot return to Earth. It was not designed for that, and the mission depends on it staying in space, away from the atmosphere that would hinder its observations. When its operational life ends, it will be moved to a safe orbit to avoid interfering with future missions. Getting Webb there was an impressive engineering feat. It remains in a delicate balance, with thrusters adjusting its position, operated remotely, capturing images that will revolutionize our view of the universe, all with $1 billion investment and no physical return home. Additionally, if Webb is hit by space debris or micrometeorites, it has shielding and redundant systems to protect its equipment. But since it's so far away, repairs or part replacements are impossible. Everything must work flawlessly on its own until the mission ends. The James Webb isn't just a giant telescope pointing at space. It's a complex machine that captures light from stars, galaxies, and even the very first light of the universe. To do this, it uses several advanced scientific instruments. each with a specific function. The main one is NARCam, the near-infrared camera, which captures images in near-infrared light. This is crucial because this light can pass through cosmic dust and reveal stars and galaxies that normal telescopes can't see. NIRCam also helps measure the distance and age of these ancient galaxies. There's also MIRI, the mid-infrared instrument, which looks at even longer wavelengths, allowing it to study star-forming regions and disks around young stars where planets might be forming. MIRI uses super-sensitive detectors and a special cooling system to operate at very low temperatures. Additionally, Webb has spectrographs that split the light into different wavelengths, enabling us to understand the chemical makeup of planets, stars, and distant galaxies. This is essential for searching for signs of life on exoplanets, for example. Each of these instruments works in sync, controlled by onboard computers and the team on Earth. They are protected by the telescope's large structure and the sun shield, which keeps the temperature stable to avoid thermal interference. It's this combination of technology that makes James Webb the largest and most powerful telescope ever sent into space, capable of showing us the universe like never before. While the spotlight is usually on the stunning images it sends back, what most people don't talk about is the intense behind-the-scenes schedule that James Webb follows. It operates on a highly controlled observation queue, scheduled months in advance. Institutions from around the world compete for even a few seconds of telescope time, and every image we see today was planned with surgical precision long ago. NASA built a system called the Astronomer's Proposal Tool, APT, where scientists submit requests to use Webb. It's a fierce competition. And here's something even more surprising. Most of Webb's observing time is already booked for the coming years, with top priorities including the atmospheres of exoplanets, the earliest galaxies, and supermassive black holes. Another little known fact: James Webb doesn't actually take color pictures. Everything it captures is raw infrared data. The colors are added later by expert teams based on the wavelengths detected. It's a process that's both technical and artistic, crucial for turning raw numbers into the breathtaking images that move the world. And there's more. Webb has already helped detect water, carbon dioxide, and even methane in the atmospheres of distant exoplanets. But that's just the beginning. Soon, it'll be used to investigate something called biosignature false positives, planets that seem habitable but might just be faking it. Oh, and one last secret. There's a kind of stealth mode in Webb's operations. Some observations are conducted in complete confidentiality, without the public knowing exactly what's being studied. This happens when discoveries are too sensitive or still need confirmation. It's cutting-edge science, with a touch of mystery. You thought the James Webb was the peak? Think again. NASA is already finalizing the telescope that will rule the skies in the coming decades, the Nancy Grace Roman Space Telescope. And unlike Webb, which zooms in on the smallest details, Roman's is designed to capture thousands of galaxies at once, in a single shot. That's right. Where Webb sees a needle in a haystack, Roman sees the whole haystack. This new giant is basically a cosmic version of a panoramic ultra camera. While Webb operates like a surgical scalpel, Roman will function like an ultra-wide lens for the universe. And it comes with the sensitivity of Hubble and the reach of Webb. Sounds impossible, but it's very real. Here's what most people don't know. Roman will have a camera with a field of view 100 times greater than Hubble's. That means it'll scan massive areas of the sky at a speed we've never seen before. Think of it as building a Google Maps of the universe, in ultra-high definition and cosmic depth. But that's not all. Roman is also set to hunt down the greatest mysteries in modern physics, dark energy and dark matter. Its mission is to build a 3D map of the cosmos, helping us understand why the universe is expanding faster and faster, something even James Webb can't fully explain. And here's the kicker. It will all happen from the Lagrange point L2, just like the Webb. But Roman is built for a minimum 5-year mission, with systems expected to last even longer. NASA believes this will be the ultimate telescope for wide-scale discoveries, from rogue planets and hidden black holes to potential signs of alien life. And here's something that might surprise you. This telescope isn't just powerful. It's also incredibly expensive. The Nancy Grace Roman Space Telescope is projected to cost around $3.2 billion USD by the time it's fully operational. It's scheduled for launch in May 2027 aboard a SpaceX Falcon Heavy rocket. And size-wise? Roman carries a 2.4-meter primary mirror, the same diameter as Hubble's, but paired with ultra-modern instruments and a camera that can capture images covering the area of 200 full moons in a single frame. It's compact, sharp, and built for cosmic scale efficiency. James Webb has already shown us that the universe is far more vast and mysterious than we ever imagined. But the future holds even more. Telescopes like Roman will open new windows to the cosmos, and who knows what we'll discover out there. If you love exploring the edge of the universe with us, you know what to do. Hit subscribe and turn on notifications. Humanity's next giant leap might just start with one click.